Hey all, this is obviously 3.8 compound inequalities, and just kind of right out of the gate, I apologize for the sloppy writing that's going to be happening here. I'm going to be like totally writing with my mouse, so that'll be interesting. But let's dive right in, okay? We've been working with just inequalities, solving for x and graphing the solution on a number line because of the technically infinite number of solutions that are normally normally included in the solution. But what the heck are compound inequalities? Well, it's actually kind of simple. The word compound inequalities really just means that there's going to be two inequalities sort of together, two inequalities that are going to be joined by the word and or the word or. Okay? And I guess the good news is these are just two normal words in the English language, right? And they're going to basically mean the same thing they mean in just everyday conversation. If you want to have, I don't know, if you want to have chocolate and vanilla ice cream at your birthday, that means something specific, compared to if you want to have chocolate or vanilla at your birthday. So let's see what they kind of mean in this context. So this is a compound inequality. It's like we got this inequality, we got this other inequality, and they're just joined by the word and. So if a number has to be less than 4 and greater than -1, what does that kind of mean? Maybe I'll do a little bit of a gray color here. But so kind of like a first draft of the graph, everything that's less than 4 would be all of those numbers, like 3 and 2 and -3 and -6, 3.5, and greater than -1. So we'd have an open circle there, and then all of those numbers, including 1 and 6 and all these numbers. So if you think about like what numbers are both less than 4 and greater than -1, again, the word and is a little bit stronger than the word or. So we're essentially looking at the overlap of these two graphs. We're looking at what they both have. What numbers are both less than 4 and greater than -1. Like what numbers are on both of these graphs. Well, then we're going to basically just have a final graph of that. Numbers like 0 and 1 and 2 and 3, but also, 3.5, -0.27, whatever. And I don't know if I'm getting a little ahead of myself, but when you have an and, okay, oftentimes it's going to be written as like this kind of thing, where you're basically in between -1 and 4. So in other words, you're talking about all numbers that are in between -1 and 4, not including 4, open circle, right? There's no or equal to here in this example. Anyway, my point is you can write it like that, like an and compound inequality is oftentimes written as like this kind of thing, where you have a number is less than x, which is less than whatever, and it's almost like a combined inequality where there's two symbols and everything. Oh, well, what do you know? This is the same thing. Okay, and I just kind of covered that, I guess. You can break this up into two, where this is like one of them. -1 is less than x. -1 is less than x, which is probably better written like that. X is greater then negative 1. And the other inequality is right here. X is also less than 4. And again, the word that connects these here is and, when it's like a double less than x, less than whatever. And again, this basically means that we're graphing everything in between negative 1 and 4. So all of those numbers. Okay, spoiler alert. These two examples, 2 and 5, yeah, and these are going to be the same thing. But I'll tell you in advance, this kind of way this is written with like a double greater than, where you have 2 is greater than x, which is greater than 5. This is rare, but this is kind of like an or thing, where x is less than 2. It's the better way to say, 2 is greater than x. 2 is greater than x. Well, x is less than 2. It's the same thing. And also we have this other one here where we can say x is greater than 5. This is an or situation. So let's graph that over here. So just think about what the word or means. X could be x is less than 2, or x could be greater than 5. So let's graph these like in gray. So x is less than 2. Well, a little bit of like a first draft. That's everything less than 2 or greater than 5. So x is greater than 5. So I mean, well, I don't want to go back to and. I'll just focus on. So what is this going to mean? That we could be like x is less than 2 or greater than 5. Would we only be able to take what's both? Like, does or mean both? Like, you have to be both less than 2? And no, it's like, it's an or. So if I said, well, is 0 a solution? Is 0 less than 2 or greater than 5? Yeah, because it satisfies this one. Is 6 less than 2 or greater than 5? Yeah, it's greater than 5. So here's what I'm getting at. When the word is or, you actually take everything. Everything from this graph, and also everything from this graph, can be a part of the final solution. So basically, again, this is going to be, sorry, I'm running with my mouse again, so it's just going to be kind of the bare minimum of. So that's the final answer. And look, spoiler alert again, like this is going to be something that is, you'll kind of find is true. When the word is and, when you have two inequalities connected with the word and, what usually, not always, right? Listen to my words very carefully. What usually happens, it's a pretty safe bet. It's not a sure bet, but it's a really safe bet that when the word in the compound inequality is an and, your graph is going to end up looking like this, where you're looking for just like in between, or these two graphs are in a way colliding, or you're taking like the overlap, only the overlap of two graphs. So anyway, this is what an and graph usually looks like, and this is what an or graph usually looks like. I remember a teacher saying, like, this kind of looks like two oars in the water, like you're rowing a canoe or a rowboat or something, or a kayak, I don't know. Maybe not a kayak, like more like a rowboat maybe. Okay, anyway. The point is, if you have two oars in the water, get it? Two oars in the water? Oh, like OAR compared to, okay. I know, very clever. But I don't know, it is. I kind of remember it that way sometimes, or at least it pops into my head from time to time that when I draw this graph, it's like two oars in the water. Like here's one oar, facing out to the right in the water. Here's the other oar facing out to the left in the water. And again, not literally every time, but almost every time, whenever the word is or in your compound inequality, your final graph is just going to end up looking like that, the two graphs running away from each other. And again, this is, to repeat myself from like a few minutes ago, this smushed inequality, it means or, but with an or graph, you're almost always going to see the two inequalities already completely separate, and you're literally going to see the word or. Where likewise, or contrary, when the word is and, you're probably, and again, I'm just kind of, like, don't quote me on this per se, but in my experience, when the word is and, you're probably going to see it smushed together like this, and you're probably not even going to see the word and literally typed there with the two inequalities already separate. Like, this is how you're going to see and problems, usually. Again, usually, this is not black or white. And with or, you're going to actually see the word or and the two totally separate inequalities that are going to lead to two separate graphs. But, okay, anyway, here we go. Some examples. First, we have to solve and then graph on the number line. Well, look at this. -3 is less than 2x minus 1, which is less than 7. There's two inequalities here, but they're kind of smushed together with a couple of less thans. So what did I tell you over the last few minutes? That this, if I were to separate these, and you could, if you wanted to write these as totally separate inequalities, you could say -3 is less than 2x minus 1. Like that middle part would just be a part of both separate inequalities. So you could have -3 is less than 2x minus 1, and the other one would be 2x minus 1 is less than 7. But the word connecting them is and when it looks like this. But I'm not going to do that. I'm not going to write them as separate. What I'm going to do is I'm going to remember that when you have a picture like, or a double inequality like this, if x is all by itself, then what this means is that it's literally in between this number here and this number here. So here's what I'm going to do, and I recommend you doing the same thing. And again, writing with my mouse. I'm going to get x by itself in the middle. Okay, I'm going to cancel that out. But remember, you're solving like two inequalities at once, technically. So you're adding one to the middle, to the right, and to the left. Wow, you have a middle, a left, and a right now. Crazy. But you know, you can handle it. So now I'm going to have a 2x in the middle, which is better. And then, but 7 plus 1 is 8, and -3 plus 1 is -2. Okay. And is x by itself yet? No. So I'm going to divide everything by 2, middle, left, and right. So now x is going to be all by itself. 8 divided by 2 is 4. -2 divided by 2 is -1. And now, are you serious? Is this the... You've got to be kidding me. Was that on purpose? I bet that this probably wasn't even on purpose. Okay, but wow. -1 is less than x, which is less than 4. Again, that means that we are in between. Again, technically this is two separate graphs, and we're looking for the overlap. But again, you should remember this kind of stuff as like just literally in between the two numbers. This one, look, two completely separate things connected with the word or. So here's what you're going to do. You're going to solve each one separately for x, and then just graph them both, and just remember the word is or. So for x, this is not horrible handwriting for a mouse, right? Hopefully I'm not screwing this up. -3 from both sides, okay. Divide both sides by 4. So there's that graph. Over here, we have to get x by itself. Subtract 7 from both sides. So we have -2x is less than or equal to what? -6. And then, oh, look at this. Dividing both sides by -2. So -6 divided by -2 is +3. But again, remember what? When you divide both sides by something negative, you immediately have to flip the symbol. And now it's going to be a greater than or equal. And again, the word is still or. So again, let's see. X is less than or equal to, so less than or equal to. So we're going to color that in now. So less than or equal to -2, greater than or equal to 3. And, you know, there we go. Okay, because again, with or, we keep everything. We keep everything from this graph, all the solutions, you know, on here. And all of these are also good because it's an or, you know. And like I said, 2 ors in the water. Look at how this graph looks. Am I surprised? No way. Not even close. Another one, they're separate. The word is or, so I know what I'm expecting for my graph to look like. Just got to get x by itself. We're going to divide both sides by 3. Do I have to reverse the symbol to a less than or equal to? No. It's only when you're dividing or multiplying by something negative. So I think that's one of them. And then, okay, oh, all I have to do over here is divide. So I get x is less than, well, you could say -5/2, right? But I don't think there's any harm right now in writing this as a decimal. It's not like we're rounding it or anything, you know, like usually fractions are better. But again, here, just to kind of, I don't know, make things as clear as possible, I'll write it as -2.5, I believe. And again, the word is or, you know. So less than, let's see, less than -2.5. That's an open circle going that way. Or greater than or equal to 4. Yeah, so, wow, look at that. Look what the graphs look like. So weird. Oh wait, it's not weird, because that's what happens like 99+% of the time. When it's an or situation, it's 2 ors in the water. And again, because we're keeping everything. Everything that's less than -2.5. Also, everything that's greater than or equal to 4. What else is there here? The last one. Okay, I mean, look, okay. So once again, these are like 2 inequalities like smooshed together. I could separate them. I could separate it into like 0 is less than or equal to x minus 1, right here. And the other one, again, kind of double dipping on the middle, the entire middle, x minus 1 is less than 4. And then the word that would connect them is and. But I can just get x by itself in the middle. So add 1 to everything. So x is here, the right side becomes 5, the left side becomes 1, and again, this just becomes everything that's in between 1 and 5. But also equal to 1. All right, that does it for that section. Thanks for following along.